today we're going to talk about how to run containers more securely. So this is like one of my favorite topics when I was discussing writing, or when Jeff offered for me to co-author the book in the second edition. I was most excited about this topic. So containers, as Jesse Frizzell likes to say, they don't exist in Linux. They're not a thing that you can look at the Linux source code and be like, oh, that's a container. I'm gonna, here's a system call or something to create a container. What containers are a whole bunch of different primarily Linux features bolted together and constructed. So there's little features are taken from the Linux file system functionality to basically put copies of files or what appear to be copies of files in the right place and construct a file system. There's C groups are a feature that you can use and configure the Linux kernel to let this set of processes or this part of a process tree use up to particular amounts of memory, CPU, disk, IO resources. So you maybe allocate 1 gigabyte of RAM but not 1.1 gigabytes of RAM. And basically there's 8 different namespaces and or C groups that help isolate a given process from the network, from other processes. So the PID namespace makes it so that a process that's running inside a Docker container can't see processes running outside the Docker container. We can give the process its own host name, or the container its own host and domain name, so it thinks it's running. If you run host name, it'll think it's running on its own. And then we can run things with other users and so forth. So we're going to see some of that today. This idea came from one of the most popular blog posts I've written, which is how to run Docker applications more securely. So I have a blog where I write about primarily cloud, security, containers, agile. It's called No Drama DevOps. Let's start with kind of the premise here. I built this little super simple web application. It's a Python Flask app. It's barely a Flask app. It's like the simplest Flask app you could probably do. We'll go ahead and, I guess I can show you the Docker file. It's cool. It's on GitHub. So it's super duper simple. It's based on Alpine and it installs Flask. That's underneath this little line. And then it adds one of the world's simplest Flask applications and exposes a port 5000 and runs Python. So requirements, it's just Flask. And the interesting thing this does is it's going to basically randomly choose one of these images from the We Rate Dogs Twitter feed. So these are cute dogs that I like. So let's build the Docker image real quick that we'll be using. So I've been testing this, so it built really quickly. Can see, yeah. So this is the same image essentially that I built yesterday. Let's run it and let's see some dogs. Just gonna run this out of the README. One thing I'll notice, or I'll call out while we're doing this, the Docker file said it exposes the application on port 5000. Well, and what that kind of means is that the container has some metadata inside it that basically tells Docker to expect people to poke a hole or connect and expose this container on port 5000. Of course, part of what it means to have your network isolated, which is up here, part of what that means is that we can change the ingress to that port and like how all that works, like where the traffic is coming in, because it has its own network interface. Like literally containers by default, they get their own network interface. So the ETH0, you can think of it, inside the container is different. And then, there's routing that takes place in the Linux kernel and networking sublayer to get traffic from outside of the container into the container through Ethernet bridging. That's another example of how containers are isolated by default. Let's go ahead and run this container right now. We're going to name it Rando Doggos, and we're going to use the Rando Doggos image that I just created. So it starts up pretty quickly, and I was testing this earlier. I shutted everything down, and now it's back. So here's a random dog. We can hit reload and see a number of random dogs. I'll make this smaller so it fits. Yeah, cute dogs, right? Okay, well, I'll say that the first thing, how secure containers is to have secure images. So you may notice, like if you go through the history here, that yesterday I updated Flask from this very old version that I created. I originally created this example like 2 years ago or something, and I upgraded it to a nice, fresh, current production release. And that's because Dependabot told me about that. So GitHub project is on GitHub, and Dependabot, I got a notice from Dependabot that it needed to be upgraded. So I did that yesterday. So like updating, keeping your images up to date and minimal is one of the first security controls, and one of the first things you should do when running your images or running your containers more securely. Now we can go ahead and move on to the actual operational controls or controls that you have at runtime to do this more securely. The first of these, there's going to be 5 of these, I think. I'm not going to read this. I guess there's 4, but I have some little adventures that we're going to include here. The first thing to do is run as an unprivileged user. By default, and this is what I'm showing right here, this is chapter 6 of Docker in Action. By default, your container runs with the root user, or to be more specific, it runs with UID 0, and that UID 0 inside the container is the same as the root user outside of the container. So in the book, we have this diagram where, look, here's the root outside. They might be the, in the default mode, the root inside the container, UID 0, is the same UID in the Linux kernel as UID 0 on the host. So now there's fancy stuff that you can do with remapping root to a non-privileged UID range and so forth. That's cool. I've done that. Obviously I did it for the book. I haven't actually met, I don't think I've met anyone. Well, I POC'd this for a client, but I don't think they went ahead and deployed that yet. The more simple thing, the thing that is hit upon in this blog post, is you don't have to do anything too fancy with your Docker configuration on the host. We can run any container as an unprivileged user. And what that means is that that's the UID of the user that the first process starts up with. So there's an example here. What we're gonna do though is I'm gonna type out the changes here. Because the number one thing you can do from a security perspective, probably, to make your containers run more securely, is to run them with unprivileged users. So that way, if and when someone does get access, they come in, the application has a vulnerability or whatever, and they get access to run things in the container, they have fewer privileges in the event of a Docker security problem, and there's a breakout. Now, Docker security has been actually very good. There's been a handful of true breakout problems, but it's an easy thing, and it prevents other problems like running tools that you shouldn't have access to. Let's go ahead and do a simple thing, which is we're going to use the user flag. Actually, let me show you. Let's just read the help real quick. Run help. Let's just type it in less. So the user option accepts a username or UID, and then you can also tack on a group ID, because you don't want the process that you're running the application inside the container as to be inside the root or wheel or some other privileged group either. So let's go ahead and modify that last command that we wrote, and we'll do user 1500 and 1500. Now 1500 UID 1500 doesn't exist or didn't exist on this server, which happens to be Docker for desktop, but it didn't exist before I ran this thing. And that's a neat thing about containers and the user namespace, in that like the UID doesn't have to exist. And in fact, like I'm not running this as my Docker exec. Like I'm not running this with a particular username. So we can see first off, I'll prove to you that the application still works. So here it's running. And if I Docker exec it rando doggos inside of it, and I run psef, you can see now that the user that app.py is running as, or sorry, Python is running as, is 1500. And it doesn't have, like if we grep etc password 1500, like there's no entry here. Like it's not like an official user or something like that, which is cool. Like there's nothing on the file system that it, grants this thing permissions other than like, other permissions it'll have execute privileges for. The neat thing is that like the application itself is readable by anyone. Python is executable by anyone. So if we say which Python, user bin Python, Python is readable and executable by everyone. And that's the reason that our app essentially it still works with this new UID. We can kind of move on to the next thing. We've exercised and narrowed our exposure here within the user namespace. Like we've got like this ad hoc created UID that's unprivileged. So boom, that's a good thing. And I picked 1500 arbitrarily. One pattern I've used is, say in your organization, you decide to run certain services on particular ports, kind of like taking Etsy services and using that for your own internal services. You can make the UID that you run the user as the same. Say the canonical port for this thing was 2700. It works just the same. Like, come back over here, still works. So, you can align your UIDs to well-known port numbers or some other identifying, like service identifying number integer. That's a neat thing I've used.